Hello guys, today I'll be explaining the Algebra 1.2 periodic quiz. So let's start. Consider the functions below with initial set R and final set R. Which of the following functions are even? What they're basically telling us in the beginning is that the initial set, which is the domain, is all real numbers, and the final set, which is the range, is also all real numbers. Now, we said if we ever want to find an even function, we must follow the equation fx equals f minus x. Or in other terms, if you put x or minus x in the same function, you will get the same result. So if we're gonna follow the fx equal f minus x rule, for the first one, we have fx equals 1 over x, and then we have f minus x equals 1 over minus x. And definitely 1 over x is different than 1 over minus x. Then, if we're gonna follow fx equals f minus x for this one, we have wx equals x to the power of 3 plus 10x. So w minus x equals minus x to the power of 3 plus 10x. Okay, so if we solve it even more, we're gonna get w minus x is equal to minus x to the power of 3 plus 10, sorry, this is not plus, minus 10x, because I forgot the minus. So definitely x to the power of 3 plus 10x is different than minus x to the power of 3 minus 10x. Then if we're gonna follow the fx equals f minus x, for this one we have ux equals x plus 1, then u minus x is equal to the absolute value of minus x plus 1. Definitely the absolute value of x plus 1 is totally different from the absolute value of x minus 1. So for example, if we had 1 is x and minus 1 is minus x, okay? We're gonna have u1 equals the absolute value of 1 plus 1, so 2. And u minus 1 is equal to the absolute value of minus 1 plus 1, which is then 0. So definitely 2 and 0 are not the same, so we know that this one is wrong. Now, if we're gonna do fx equals f minus x for this one, we have gx equals 5 absolute value of x, then we have g minus x equals 5 absolute value of minus x. So then if we solve it even more, we're gonna have 5 absolute value x, 5 absolute value x, and 5 absolute value x are equal. So then we say yes, this is an even function. Now remember fx equals f minus x, okay? We have hx equals the absolute value of x. We're gonna now take h minus x is equal to the absolute value of minus x, which is the absolute value of x, and definitely absolute value of x and absolute value of x are equal, so then it is an even function. Finally, we have vx. We remember fx equals f minus x. We have vx equals x plus 4. So v minus x equals minus x plus 4. X plus 4 and minus x plus 4 are not equal, so then it's not even. So the only two answers are gx equals 5 absolute value x and hx equals absolute value x. Question number 2. Select the graphs that represent one-to-one functions. First of all, whenever they say one-to-one functions, we have one-to-one relations and one-to-one functions. Whenever they're talking about one-to-one functions, we first have to do for the functions the vertical line test. And then for the one-to-one, we do the horizontal line test. Now here we can do very easily the vertical line test like this. So this is a function. This is also a function. Also a function. So basically, if you're gonna do it, you're gonna find out that they are all functions. Okay? So we finished from the vertical line test. We found out that they are all functions. Now we need to find out if they are all one-to-one functions. So we do the horizontal line test. So it's not one-to-one, not one-to-one, not one-to-one. It is one-to-one. It's not one-to-one. And it is 1-to-1. So the only two answers are this one and this one. Question number 3. In each box, enter the letter corresponding the best description. We have A represents a 1-to-1 relation, B represents a many-to-one relation, C represents a 1-to-1 function, D, the graph represents a many-to-one function. So if we look here, we can say, first of all, this is a function. If we do the vertical line test, so 1, 2, 3, 4, 5, 6, 7, it is a function. How about this one? If we do the vertical line test, it's not a function. And this one, if you do the vertical line test, you will see that it is a function. So the first one and the last one are functions, and the middle one is not a function. Now we need to check which one is one-to-one and which one is many-to-one. So directly, this is not one-to-one, so it's a many-to-one function. Then we have this one. It's also not a one-to-one, so it's a many-to-one relation. And then this one, it is one-to-one, so we say it is a 1-to-1 function. So a many-to-one function was D, so this is D. Oh my goodness, D. Okay. Then the second one, we said it was a many-to-one relation, so it is B. And then the first one, we said it's a 1-to-1 function, so then it is C. So that's it for question number 3. Question number 4. Which of the following are 1-to-1 functions? Again, we need to check, are they a function? And then we check, are they 1-to-1? So first, which ones are functions? Definitely this one is not a function. And definitely this one is also not a function. And also this one is not a function. So we're left with this one and this one. To check if they're 1-to-1, we do the vertical line, the horizontal line test. So this one is a function, and this one is a function. So these are the only two that are functions out of the 5. Now question number 5. Consider the function g defined by the rule gx equals this. Okay, they're telling us g, 1. So we put 1 instead of x. So g1 is equal to 3 times 1 to the power of 3 minus 2. So then g1 is equal to 3 times 1 minus 2, which is minus 1. So 3 times minus 1 is minus 3. So g1 is equal to minus 3. Now g minus 1, we're going to put minus 1 in x. So g minus 1 is equal to 3, okay, times minus 1 to the power of 3 minus 2. So g minus 1 is equal to 3 times minus 3, so minus 9. So g minus 1 is equal to minus 9. Now definitely it's not even and not odd because they're two different values, so it's neither even nor odd. So by looking at the options, we have it's not even, it's not odd, so it is not an odd function. Question number 6. Consider the function f(x) equals 5x minus 4 over x. Pick the steps that can be used to prove that f(x) is an odd function. So if it is an odd function, we said we do either f(x) equals minus f minus x, or f minus x is equal to minus fx. Either way works, okay? So this one, you're saying that function x is equal to minus times function minus x, and this one you're saying function minus x is equal to minus times function x, and these are both correct for the odd functions. Now they're telling us, consider this function. We need to prove that it is odd. So we said we're going to use either f(x) equals minus f minus x, or f minus x is equal to minus fx. Okay? So, if we look at the options, we have f minus x, okay, is equal to 5 minus x minus 4 over x. This is wrong. Why? Look, here we put minus x, so far we are correct. But here we kept it as x. We need to put it as minus x, so this one is wrong. How about the next one? We have f minus x is equal to 5 minus x. Yes. Minus 4 over minus x. Yes. So this one is correct. Then, if we simplify it, we're gonna get minus 5x, and then two minuses in a fraction make it positive, plus 4 over x. So that means f minus x is equal to minus 5x plus 4 over x. So this one is correct. This one is a contradiction, so we don't choose it. And then finally, we said if it is an odd function, we have that f(x) is equal to minus f minus x, or f minus x is equal to minus fx. So which one of the ones that we wrote can you see? It's definitely not this one, so this one is our answer. So for question number 6, these are the 3 answers. Question number 7. Consider the function p defined by this rule. Okay, first of all, we're going to substitute the x with 3. So p3 is equal to 3 plus 2 squared plus 4. So p3 is equal to 25 plus 4, which is 29. So p3 is equal to 29. p minus 3, we're going to substitute the minus 3 in the x. So p minus 3 is equal to minus 3 plus 2 squared plus 4. Then we're going to get it's equal to minus 1 squared plus 4, which is then 1 plus 4, which is 5. So p minus 3 is equal to 5. So that is for part A. Now for part B, look, this value and this value are in no way similar, are in no way equal. So it's not even and not odd. So it's neither even nor odd. So it's not an odd, it's not an even, so we choose the option that it is not an even function. Now, which of the following are even functions? We said anytime we see even functions, we do fx equals f minus x. Or, in other terms, x and minus x, if we substitute it, will give us the same result. So, if we substitute it, so first of all, we have hx equals x to the power of 4 plus 4. And we remember fx equals f minus x. So we have hx, let's take h minus x. It's equal to minus x to the power of 4 plus 4, which is then x to the power of 4 plus 4, because if you have an even exponent, it will remove the minus. So now, x to the power of 4 plus 4 is equal to x to the power of 4 plus 4, so it is even. That means the first one is even. The second one, h minus x is equal to 4 times minus x plus 1. So then we get minus 4x plus 1. Definitely 4x plus 1 and minus 4x plus 1 are not the same, so it is not even. Okay? Hx equals 2x minus 1 to the power of 2. We're going to take h minus x. H minus x is equal to 2 times minus x minus 1 to the power of 2. Okay, so then we're going to get minus 2x minus 1 to the power of 2. And definitely 2x minus 1 is very different than minus 2x minus 1, so it is not even. Then we have hx equals absolute value of x plus 3, so h minus x is equal to absolute value of minus x plus 3, which is then the absolute value of x plus 3. So this and this are equal, so then it is even. Then we have hx equals x squared minus 6, then h minus x is equal to minus x squared minus 6, which is then x squared minus 6. So x squared minus 6 and x squared minus 6 are equal, so then it is even. This is even. And then finally we have hx equals x plus 1. How about h minus x? H minus x is equal to absolute value of minus x plus 1. Definitely x plus 1 and minus x plus 1 are different, so it is not even. So these are the only 3 answers for number 8. Now we move on to question number 9. Consider the graph of the function g shown below. Fill in the blanks with the correct numbers to give the maximal interval over which g is 1 to 1. When g is 1 to 1, we said we have to do the horizontal line test. So if you notice here, if we do the horizontal line test, this over here, and if you do it over here as well, and this over here, they are not 1 to 1. Whereas if you take this part over here, in this blue box, and you do the horizontal line test, you're not gonna see that there are 2 points on the same line. So then we can say that in this box, they are 1 to 1. Okay? That means, what are the points that make them 1 to 1? We have the y is 3 and the x is minus 3. And then we have the y is minus 3 and the x is 4. So that means what? They're asking us what? They're asking us x. Okay, it has to be greater than a number and smaller than a number. If you go back and we check what we pointed for x, we pointed minus 3 for x and we pointed 4 for x. So tell me, if it goes beyond 4, if it becomes a number greater than 4, will it become 1 to 1? No. So it has to be all numbers less than 4. So we make the biggest number 4, and then it is equal to x. Then, if you look here, then we have minus 3. If we choose any number smaller than minus 3, will it become a 1 to 1 function? No. So that means x has to be greater than or equal to minus 3. So our final answer will look something like this. So minus 3 is smaller than or equal to x, and x is smaller than or equal to 4. Question number 10. Which of the following statements is true? We have gx equals 5x to the power of 3. They're telling us g minus x is equal to 5x to the power of 3? No. g minus x is equal to minus 5x to the power of 3. So this one is wrong. Now, g minus x is equal to minus gx. Let's see, we have 5x to the power of 3. If we put minus x, we're going to have 5 minus x to the power of 3, which is then minus 5x to the 3. Gx, we said, it was 5x to the power of 3. If we put a minus in front of the 5x, okay, then it will become what? It will become minus 5x to the power of 3. So definitely minus gx is equal to g minus x, because minus 5x to the 3 is equal to minus 5x to the 3, okay? So then we say it is odd, okay? So this one is correct, and it is an odd function. Now, the domain is the set of all real numbers. If you go back and you look, there is nothing that restricts this. So the domain can be the set of all real numbers. So this is also true. Then, we already solved this. We said g minus x is equal to 5 times minus x to the power of 3. So this is correct. And we said that g is an odd function. So for question number 10, there are 4 correct answers. Question number 11. Consider the function gx equals x squared plus 4x. Which of the following statements is true? So, they're telling us g minus x is equal to gx. Let us see. If we put minus x here, we're going to have g minus x is equal to minus x to the power of 2 plus 4 times minus x. So then we're going to get x squared minus 4x. So this and this are not equal, so it's not even. So definitely this is not true, okay? We do not choose it. Sorry. And we said it's not an even function, so this we choose it because it's not an even function. Now, let's see. Is it an odd function? We said for an odd function, we do gx equals g minus x, okay? So, or g minus x is equal to minus gx. So gx is equal to x squared plus 4x. G minus x, we said it was x squared minus 4x. Then, okay, if we multiply the g minus x by minus, what will happen? We will then get minus x squared plus 4x. So definitely this one and this one are not even. They're not equal, okay? So they are not even. So definitely, sorry, so they are not odd, not even. We said this one, and we did minus g minus x, we got minus x squared plus 4. Definitely this one and this one are not equal, so it is not odd, okay? So it is not an odd function. So this is not true because we tried it, so it is not true. And this is the rule for the odd function. And then finally, gx is defined in the set of all real numbers. So if you put any number in here, and you put and you substitute the x with that number, there will be no restrictions. So definitely it's defined in the set of all real numbers. Question number 12. G is 1 to 1 for all x greater than or equal to k. Okay, what is the smallest value of k? Now, about this question, what do we do in it? We take the value inside, okay? We have x minus 6, okay? We make it then different than 0, or not always different than 0. You just take the x minus 6 and you make it equal to 0. Then you bring 6 to the other side, you're going to have x is equal to k. So, to 6, not to k. So we get that the value over here is 6. This is one way of solving it. Another way of solving it is directly when you see in this form an equation. For example, I remember in the AMS it came like 3x minus 5 squared minus 10, something like this it came. And so what we had to do was you take the number inside, minus 5, then you choose the opposite, which becomes what? 5. So your answer is then 5. Same here. You take the number inside, minus 6, take the opposite, 6. So our answer is 6. So that is for question number 12. Question number 13. The graph of a function g is shown in the diagram below. G is 1-to-1 for all x less than or equal to k. So what is the largest value of k? They need it to be what? A 1-to-1 function. Yes? So if we draw the horizontal line test, we will notice that, first of all, here, if we draw a line from here, okay, then this over here will become 1-to-1, and this over here will become 1-to-1. Again, I will repeat. We do the horizontal line test, and then we see at which point possibly if we draw a vertical line from it, it's definitely this point, okay? The function will then become 1-to-1. So, this is now a 1-to-1 function, and this is now a 1-to-1 function. Now they're telling us that x is less than or equal to k. They need the largest value of k. طيب, if we chose 2, for example, if we choose our x has to be less than or equal to 2, will it then be a 1-to-1 function? Because look, all the values less than or equal to 2 follow the whole curve. So definitely this is not 1-to-1. Okay? But then if we chose, for example, 1, again, it's not gonna be 1-to-1 because look, these two are on the same horizontal line. So it's not 1-to-1. But then if we choose 0, let me choose a different color. If we choose 0, okay, and we go all numbers less than 0, then definitely 0 is 1-to-1. So that means the largest value of k, or that x has to be greater than, less than or equal to 0. So the largest value of k is then 0. Again, I will repeat. They're asking that x has to be less than a number for the function to be 1-to-1. Okay, we said if we choose 2, it's not gonna be 1-to-1. And if we chose 1, it's not gonna be 1-to-1. But then if we chose 0, it is gonna be 1-to-1. So that means the largest value of our x can be 0. So our answer is 0. Question number 14. Which point, if removed, makes a 1-to-1 function? We said 1-to-1 function, there should be no 2 points on the same horizontal line. So directly we have A and B on the same horizontal line. So you can remove either A or B and you will get the correct answer. So A is correct and B is also correct. So let's submit and see. Thank you guys for watching. I hope you understood and have a great day.